This is a brief overview of confirmatory factor analysis by Dr. Jennifer Ripley at Regent University in her statistics class. So this is a quick introduction just to get you some basic ideas about confirmatory factor analysis, primarily as an understanding of it and how it is different than regular factor analysis or principal components analysis. So a few things that are really important about CFA. It is based on a hypothesis, right? So it is not just like factor analysis where you just take data and you kind of throw it up on the wall and you see what sticks. With confirmatory factor analysis, you have a hypothesis or preset ideas on which items or which variables would fall into which groupings. So for this, then you might take a bunch of items about hopelessness, sleep problems, and lack of sexual desire and have them fall onto a depression subscale, whereas you might have items about restlessness, worry, and fidgeting and have them fall into an anxiety subscale. And this will test to see if the way that you set up your model is a good or best fit with the data that you gave the computer. Now, of course, all data has error involved in it, so nothing's ever going to be perfect, but you want to see whether that model is a good fit or whether maybe there's a different model, so a different way of doing things would be a good fit. SPSS does not do confirmatory factor analysis, so this is where we hit one of the limits of our course, of the Sci 714 course that I teach here at Regent. It would require one of three programs that are popularly used for it, either Literal, AMOS, or EQS. Those are the most commonly used ones, although people are using M+ now for a variety of models, and I believe it can do that as well, so that's kind of a new one. R also might be able to do it. I actually haven't investigated that one yet. Typically, you're going to be testing that there are some number of factors. So say I'm going to say, okay, I think I have one factor, I think I have two factors, but I'm not 100% sure, so I'm going to test a one-factor model, and then I'm going to test a two-factor model. So that's what I did for my dissertation, for instance, to see which one has the better fit, and that's information about the data that you have. To do a really good job with a scale, you really should do a factor analysis first on a sample, and then collect another sample and do a confirmatory factor analysis on that sample so that you get kind of two lenses into the data to see everything that you can about how it is all fitting together. If you were reading an article with a CFA, then you're going to have a fechi things just to give you some hints on it. One is there's model fit statistics, so you'll look through and you'll see people often will still report chi-square, but pretty much everyone agrees that it's too sensitive. And actually, I'm starting to see it fall off in the literature in terms of articles presenting it and just presenting the comparative fit index or a similar type of fit index. Comparative fit index is a common one, and it's a pretty simple thing to understand, which is great for students who are new to it. Point A is 8 is considered okay, 0.9 is considered great, and 0.95 or higher is considered terrific. 1 is the highest you can get in a comparative fit index. For the model, when you read it in an article, you're going to see these pictures, and the boxes that you see are items, so questions in a questionnaire typically is what we'd be looking at in psychology research, and they're going to be assigned to factors, so a line in the data, right, or latent variables. Those factors are going to be circles in your model, so you're going to see a line going from your item box to your circle, and it shows you which factor that the researchers assign the item to a priori, so in their hypothesis. And then it'll tell us how well the items or measurements or observations, whatever it is that you're doing, fit into the factors. Principal components analysis and exploratory factor analysis tells us which items go where, but not really how well it fits. It can't answer that question. So only confirmatory factor analysis can answer that question. So this is a picture of a confirmatory factor analysis here. It's a little more thorough than you might see in some articles, but what you'll find here is that there is, in the boxes on the left are your items. So you see items 1, 3, 4, and 6 are in purple, and items 2, 5, and 7 in blue. The purple items are the ones that the researcher decided a priori before the study was done would be depression items, okay? And then next to those are little E's. You see the little boxes with E's. Those are error terms. So every question is going to have error term associated with it, right? So unique error for each item. And so that's in the model. Whether or not you actually see it in a presentation in an article or not is kind of a different matter, but you do get it that way. And then you see these factor loadings here. 0.44, for instance, is the factor loading of item 1 onto factor 1. Now this is similar to the factor loadings that you saw in the factor analysis that we did before. So it's not a correlation, although it has some similarities in terms of its strength, and kind of a strength of association measure, but it is a factor loading actually. So just like in principal components analysis, it tells you, oh, item 1 loads onto factor 1 at 0.44. It typically does not give you anything else because you have forced item 1 onto factor 1 essentially. So while item 1 does have a relationship with factor 2, because you have forced it in confirmatory factor analysis, that's not something that's being examined. It would be considered error variance in the field of data. So items 2, 5, and 7 have been forced to load onto factor 2, and you can see their loadings there. If you use a 0.3 cutoff, in your previous research, then all of these items would fit nicely. Typically, you're not going to put items on here that haven't fit nicely in previous research. I don't know of anyone that does a confirmatory factor analysis first before they've tried a factor analysis with data. But, anything's possible in the world of research. So one other thing you see there is the relationship between the two factors you can get in confirmatory factor analysis. And this is telling me that factor 1 and factor 2 relate at about a 0.23. So similar to a correlation, this is their relationship with each other and the strength of association. So this gives you a nice big picture. It's different than the picture of a regular factor analysis, but it's usually fairly easy. Most students can kind of understand a CFA model fairly easily and understand what it's being communicated here and how well things are loading on everything to understand what it is that you're looking at. And then the other thing you're going to look at, of course, is the fit index. Sometimes they give 2 or 3 fit index to see overall the whole big picture of everything you see here in this picture. How well does everything fit? So if you get like a 0.90 or something like that, you're great. You're happy because you've got a really great fit. One final thing to understand, that whenever confirmatory factor analysis is going on, it's actually really a structured equation model behind the scenes. So inside the computer, it's essentially running a structured equation model, something very similar. So that's really what that is for most CFAs. So when we hit the word model, we have reached the end in our boundary on the Statistics Sci 714 class for the PsyD program, meaning we're not covering models in this course. However, you are likely to need to know about this in your future. So in our program, you'll have a dissertation, you'll need to read articles. The articles will have models in them, either structural equation models, confirmatory factor analyses. They might have hierarchical linear modeling or other kinds of models. So what are you going to do? One is that you're going to work on your own to try to understand it a little bit better. You can do that. But if you actually need to conduct models in your future, there are classes at professional conventions such as the APA convention that do like a one-day training in structured equation models. They've done that for many years. That might be something you could consider doing. Universities often have classes in advanced statistics. You could go do that if you were wanting to be able to do models in the future in your research, in your profession. Go to a local university and take some classes, or you could find a colleague who can kind of do the modeling for you, and you get tutored by them, and they kind of teach you how to do it. So there are a variety of ways to do this. I've been doing option number 3 and trying to learn modeling, and having people work with me and teach me how to do it along the way. So it depends on whether you have colleagues available to you, I suppose, whether you can do that. So just kind of like here we've hit the end of the road in terms of types of statistics, but I want you to be aware that there's a whole other area of psychology statistics that are commonly used, and even more commonly used now than the basics of what we covered in your course, are the models, the various different model statistics. So just be aware there's more to learn.